Let's solve. We're going to solve. I don't know why I felt like singing that. But we're going to solve these for radians. So I'm not going to use degrees because we're adults now. But we're going to solve for radians, and we're going to restrict our answers to the domain from 0 to 2 pi, including 0 but not 2 pi, which means that if we have an answer that is 0, we will include the 0 but not the 2 pi, because 0 and 2 pi are really the same angle measurement. They're in the same location. So I want to know everywhere that sine is negative square root of 2 over 2, and here's the obvious. I could bump the camera. Let's do that. I want to find everywhere that sine, the x value, or the y value, sorry, is negative square root of 2 over 2. It's not those, but it is these. So it's those two answers right there, which would be 5 pi over 4 and 7 pi over 4. And yeah, let's grab the paper. Let's do it. It'll be fun. Fantastic. But in a minute, we're not going to use the paper. We're going to start really thinking through this logically. Actually, let's go ahead and start with this one. I want everywhere that sine is negative, so I'm going to have an answer here and I'm going to have an answer here. And I hope your mind is going back to this right here. That's going to come in handy. So I know I'm dealing with things in this quadrant, which these two quadrants, which is greater than pi and still greater than pi and close to 2 pi. And square root of 2 over 2 is kind of the halfway mark in our little song. It would be like sine counts back with 1. I'm saying things with the wrong signs. They're going to be negative here. But sine counts back with 1, square root 3 over 2, square root 2 over 2, 1/2 then 0. There you go. There's your square root of 2 over 2. There it is. And that happens at 5 pi over 4. And it also happens here. Sine counts back with 1, square root 3 over 2, square root 2 over 2, although it's negative. 1/2 then 0. Okay, tangent is 1. Well, where is tangent 1? There and there. That'd be quadrants 1 and quadrants 1 and 3. And tangent is 1 when y and x have the same coordinate. That happens at 45 degrees, but we're adults, so we don't talk degrees, we talk radians. That's pi over 4 and 5 pi over 4. Yes, you just saw that answer. The 5 pi over 4 part anyway. So if you need to see it visually, here it is. This is where tangent is 1. There it is. I need everywhere that tangent plus square root of 3 is equal to 0. Well, let's solve because we're smart. So the tangent of theta is equal to negative square root of 3. And let's see what we can find. I want everywhere that tangent is negative. Tangent is negative here and here. Now I need to know exactly where those are. The square roots of 3 are a little closer to the y-axis. I probably should have drawn this a little steeper. But it's at 2 pi over 3. You get the hang of this after a while. And the one that is just beyond 3 pi over 2. And that would be 5 pi over 3. There we go. You can verify that on the unit circle if you like. Let's start going a little faster. I think as we go through these next two, it's going to be obvious that you have a little solving to do. So I'm skipping ahead. Cosine is equal to square root of 3 over 2. Oops, negative. I need everywhere that cosine is negative. That's going to happen here and here. Cosine starts with 1, square root 3 over 2. All right, that would be 5 pi over 6. And this one also is going to be 7 pi over 6. All right, sine is equal to 1/2. I don't know why I wrote that in the middle of everything. I'm switching places where I write things. Sine, cosine starts with 1, square root 3 over 2. Sine counts back with 1, square root 3 over 2, square root 2 over 2. 1/2, that would be 5 pi over 6, and positive pi over 6. I put those in the wrong order. I'm sorry. All right, now we really start solving. Ha 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 ha, maniacal laughter. This is going to involve factoring, but you've factored before. Like if this said, not what it says, but if it actually said 2x squared plus square root of 2 times x equals 0, you'd say, oh, look, I have a GCF. I'll factor out an x. And you would have that, right? That's exactly what we have. It's not x, it's sine theta. That's what it really is. So let's factor out a sine theta. I'm going to factor out sine theta. And I have 2 sine theta plus square root of 2, and that's equal to 0. And we're going to set each factor equal to 0. So sine of theta equals 0. And 2 sine theta plus square root of 2 equals 0, which means I'm looking for everywhere that sine is 0. And that happens here and here. And we could say 2 pi, but nah, let's not overdo it. And then we're going to have more answers that come from this side, and that's everywhere that sine is equal to negative square root of 2 over 2. Sine is negative square root of 2 over 2 in these two quadrants. Whew, that was poorly drawn. Sorry about that. This is, it's multiple of 4. That'd be 5 pi over 4. And 7 pi over 4. You can verify that if you like. I have 4 answers that would satisfy that. All right, as we get to the next one, you're probably like, well, why don't we just square root? Yeah, why don't we? Let's do it. If I square root both sides, I'd have, well, 1. But I have plus or minus 1. So I need everywhere that cosine is positive 1, which is here. Everywhere that cosine is negative 1, which is here. And that's it. All right, now we get to the crazy one. I'm going to shift colors, or change colors. It's shift colors, like I'm a chameleon. Pardon me while I shift colors. I'm going to pretend like this says that, because it does, but it doesn't, but it does. We're just going to factor it, okay? Like you know how to factor. I need a couple things that multiply to give me 2, maybe 2 times 1, they're both positive. So I really have x equals negative 2 and x equals negative 1, okay? That's what I'm dealing with. This process is this, only it just has signs in it. I know, they're all positive, right? Boom. Thanks, I'm here all week. Sine theta plus 2, and then sine theta plus 1. So I'm looking for everywhere that sine is equal to negative 2, and I'm looking for everywhere that sine is equal to negative 1. I'm going to go ahead and jump at this one. I like that one, easier. Low-hanging fruit. Grab that first. Everywhere that sine is negative 1, that's the y value, that's going to happen at 3 pi over 2. You can verify that by looking at your unit circle. It's the y value of negative 1 on the unit circle. That'd be 3 pi over 2. Now, this one, you'll never find it on your unit circle, and you'll never find it. Like, you won't find it. It's not there. And here's why. I'm looking for where sine is equal to negative 2. Notice this graph that we did earlier. Sine values, outputs for the sine function, wobble, for lack of a better word, between positive 1 and negative 1. The range is negative 1 to 1. But I'm looking for negative 2. You'll never reach that. Now, if we had a difference of amplitude or something, that would shift things, not shift things, it would stretch things. But it would make that possible, potentially. But right now, it's not. So I got no answers from that. This actually is no solution for this part, but I do have a solution for this factor. So we'll keep that one. All right, last one. And this one is tricky to factor, and we're just going to go for it. All right, so it's the same kind of process I wrote in green here, only the numbers look crazy because there's a square root of 3. So I know I'm dealing with tangent times tangent, and that's pretty obvious. I need 2 numbers that multiply to give me square root of 3, negative square root of 3. So I know my signs are different, first of all. Got that. What multiplies to give me the square root of 3? Don't think too hard. Don't be like, oh, the square root of 1.5 times the square root of 2. Don't play that game. Don't play. Don't. It's staring you in the face. It's right here. Square root of 3 times 1. And the square root of 3 is negative. If you were to grab a scrap piece of paper, my new favorite piece of paper, and you were to multiply this out, you'd have tan squared minus square root of 3 tan plus 1 tan minus square root of 3. And these two terms together, well, you could factor a tan out, but we'll put the numbers in the front, and we'll have negative square root of 3 plus 1. I'll get it where you can see it. That'd be nice. Yeah, I want to learn too. Can't read your mind, sir. That is that. There you go. So what we're going to do is solve this, set it equal to 0, set each factor equal to 0. Let's go ahead and solve some things. Tangent is equal to negative 1. Let's go for it. Tangent is negative 1 in quadrants 2 and 4, and that happens at 3 pi over 4 and at 7 pi over 4. And I'm also looking for everywhere that tangent is equal to the square root of 3. Tangent is equal to the square root of 3 at pi over 3 and at 4 pi over 3. So if we put them all in order, I'd put a comma there.